linked list.
Okay.
So here we are taking 3 extra pointers. One is head pointer, previous pointer, and current node.
Okay.
Okay. Now what we are doing is simply take, this is our now we are moving this head to the next node. Head is the starting node, right? So we are moving the head node, and current node also we are putting as second node.
Okay.
Now current node is second node, head node is second node, and previous node we are saying it as head node.
No.
Okay. Now what we are doing is, now the previous node now, which is the first node, contains the address of current node.
Yeah.
Right? 10 contains the data, 10 has an address of 20.
Yeah.
Yeah. But the last node, in reverse node, the last node must have null, which is there at 40.
Yes.
Right. So we are making this 10th previous node as null node.
Okay.
Okay. Now previous node doesn't contain, now your head node does have 20, current node is also 20, and previous node does have a null address. Right. Now we are incrementing the head address because we have to move head address. So now head address becomes 30. This is our previous node, this is current node, this is head.
Okay.
Okay. Now what we have to do is, this current node should have the address of 10.
Okay.
Right. So we are moving this current address next address, the current node next address to 10th.
Right. Okay.
Previous node. We are assigning this current node's address to previous node.
Okay.
Right. Now our head is 30. Previous node doesn't have any address, which is null, and now our current node is pointing to 10, which is previous node.
Okay.
Right. Now already we have head, one is previous node, current node, head is pointing to 30 and 40 is pointing to null. Now what we need to do is, now here if we see, make this previous node as current node, and current node just to forward it to 30. Now we have to do nothing with 10, which is previous node. 10 already we have assigned null to 10, as well as 20 we have assigned with 10. So now we don't need previous node pointing to 10. So now previous node we will increment to 20, and the current node which is pointing to 20 we will point it to 30.
Okay.
Right. We are just incrementing our pointer.
Okay.
Now head node is 30, current node is also 30, and previous node is 10. Now we have to assign this 30th node address to 20. We have to reverse it. So now 30 is pointing to 40 actually, but 30 should point to 20 now.
Okay.
Right. You got this?
Can you explain it again from start?
Actually it was sorry.
Can you explain it from the start?
From?
Start, sir.
Start.
Yeah.
Okay. Fine. Now here we have 4 nodes, and I am not saying it as present node or current node anything. I am just naming this node as 10, 20, 30 and 40. Okay.
Okay.
Now what we are doing is, right now our head node, current node, previous node, everything is pointing to 10.
Okay.
Starting. Now we are saying that previous node is this 10 is pointing to 20, 20 is pointing to 30, 30 is pointing to 40. So we are taking 3 extra pointers.
Okay.
And pointing those pointers, we are calling it as head, current node, and previous node.
Okay. Yeah.
Now, head is pointing to, head is the first address which is pointing to 10 actually.
Okay.
We are incrementing that and we are making it to point to 20.
Okay.
Okay, which means now our head is pointing to next node, which is 20. And here previous node contains the address of 10 and current node is also pointing to, now current node we are just incrementing it, which points to now 20. Now head node is 20. Now that means the starting node is 20 and current node is also 20.
Okay.
We are taking simply 3 pointers, that's it. We are incrementing the pointer to point to the second node. Now when we do this, we know that 10 should not point anywhere. Why? Because in a reverse list, the last pointer should point to null. It means 10 should also point to null. But 10 points to 20 right now. 10 is pointing to 20. 10 holds the address of 20. So we need to make 10 points to null.
Okay.
Okay. So simply we are making it point to null, writing like previous node next should contain null.
Okay.
Okay. Now 10 doesn't point to anything and we are just, it's not holding any address. It's just holding null. Okay. Now 10 should not do anything. We can leave 10. Why? Because 10 is not pointing anywhere. But our 20 is pointing to 30. But now 20 should point to 10. Because we are reversing it, right?
Yeah, then okay.
So now the 20 next should point to 10.
Yeah.
Right?
Yes.
20 holds the address of 30. But 20 should hold the address of 10 now.
Okay.
So what we are doing is, here we are incrementing this head first.
Okay.
Head pointer we are incrementing to 30. And then we are moving like, after incrementing it, we are simply saying that now the current node of this 20 should hold the address of previous node, which is 10.
No.
We are simply taking this current node and the current node next should have previous node address. It should point to previous node. Still confusing?
Yeah, now I understand.
Okay. Now 10's work is over. 10 is simply pointing to previous node. But right now we don't need the value of that node. So what we are doing, we are making this previous node increment to 20. We are just making that now previous node should point to 20 and the current node should point to 30.
Okay.
Okay, because we don't have any work to do on 10. Already 20 holds the address of 10.
Okay.
Now we have to make 30 hold the address of 20.
Okay.
So for that, we are just making current node as well as head node at 30 and previous node is now 20.
Okay.
Now 30 should point to 20. 30 should hold the address of 20 now.
Okay. Okay. Yeah.
Why? Because we have 30 should hold the address of 20. So here we are making this 30 to hold the address of 20 and now previous node is 20, current node is 20, increment this head address.
Okay.
Okay. Now after this your head should now point to 30.
30. Yeah.
Right? 30.
Yes.
So we are saying previous node is 30, current node is 40, and now this 40 should not have null address, but it should hold the address of 30.
30. Okay.
Okay, so this is the pictorial representation of whatever we are going to write in our program.
Okay. Okay.
So now we will see the program. Now if you see the reverse function, we are taking some linked list, and now if we see our linked list reverse function, so if you see this function, now first we are taking previous node as well as current node, and current node is taking again head. This is head is pointing to our base structure. Okay, this head is nothing but this whatever we are passing to this reverse function. So basically it is pointing to our main linked list, and we are taking one previous pointer which is pointing to null. Now first we need to traverse the list, and we are saying that while my current node is not equal to null, current node is already starting node which is head, so it is not null.
Okay.
Right. If it is not null, just what we are doing is we are incrementing this current node, right? We are just incrementing this current node to point to 20. So here we are saying that we are taking one more pointer which is next, and we are making this to point to the current next.
Okay.
Whatever your current next contain holds, we are storing it in one pointer called next. Okay. Now current next should have previous value. We are increment whatever previous node contains. Previous contains null. Okay. Current is also first one right now. It is base address at starting.
Okay.
So previous does hold null. Previous hold null. That means the first node we have made null. The first one we have made null.
Okay.
This one.
Yeah.
This step is done.
Okay.
Null. Now our current node, current next is equal to previous. Previous does hold a value of null. So first node we have made null. Now we are incrementing the pointers. Previous is pointing to current, and current is pointing to next.
Okay.
Okay. Again we are checking that whether current is not equal to null. No, current does hold the address of next node.
Okay.
Which is the second node.
Yeah.
And we are doing the same operation again.
No.
I hope it is clear now.
Yeah.
Okay. Oh. Yes. Okay. So this was for reverse linked list. Now coming to your circular linked list. In circular linked list, we do have to follow some steps, which I'll say you. 1 minute. Now. Already I said you what circular linked list have one thing, which is like it should not have null address. Okay. Circular linked list doesn't have a null address, but the last node will again point to the first node.
Yeah.
Right. So steps to write that function will be almost it will be same, but the only thing will be like if at all if your first pointer is pointing to when we said 10, 20, 30, so 10 will point to 20, 20 will point to 30, and 30 will again point to 10. Okay, and just for reference, what we will do is, if we want, we will hold the address of this one like some address of 30. Why? Because we are not storing address of 30 anywhere. 30 doesn't hold anything, right? 30 holds 10, sorry. This is for linked list. Okay, circular. So we don't need this. So in this way, we are holding the address. So when we want to, now here also we are doing some operations on circular linked list for insertion, where we are inserting the values in linked list, whether we are inserting it in starting or in between or at end, where we are inserting values here. So depending on that, we will have to follow some, again, we will have to follow like if we are inserting it at, now first what we are doing is inserting at the beginning. Okay, at starting if we are doing, so the steps we will have to follow is already 10 holds the address of 20, right? That means now if we are inserting a node at starting, 10 address should be there in some other node. That means if we are inserting something like 5, now 5 should hold the address of 10.
Yeah.
Right. So simply what we need to do is we need to add a new node, make that point to 20. Okay, and make this 5 as head node, because right now head node is 10. We have to make the 5 as head node.
Okay.
Right. Now,
Yeah.
if we are doing it at between some node, if we are inserting any element at some node, then what we need to do is, first we need to travel where we need to insert the node. Now suppose I want to insert a node in between 10 and 20.
Okay.
So at that time, what we need to do, take a new node. After taking new node, now 5 is my new node, suppose. So now what I should do is 5 should point to, first I have taken 5, and after taking 5, what we are doing, holding the address of 20. That means now 5 should point to 20.
Yeah.
right? At the same time, now your 10 should not point to 20. 10 should point to 5.
5. Yeah.
Right. So
Yeah.
this is inserting in between.
Okay.
Right. If we want to insert it at end, at that time, what we need to do is just take this 5, and now 5 should not have anything. Why? Because this is the 5 should have 10's address. 5 should not have 10. 5 should point to 10, right? Because this is the last node.
Yeah.
At the same time, 30 should point to 5. Right.
No. Yeah.
If we want the same things, if we want to delete at that time, if for deleting operation also, what we need to do is, if we are deleting the first one, now if I'm deleting this 10 nodes, it will simply have 10 node, no problem, right? But 30 should now point to 20. If we are deleting 10th node,
Okay.
at that time, now my 30 is pointing to 10, right? But then 30 should point to 20, because already we deleted 10th one.
Yeah.
This is deleting it. Any node you delete, same thing will be there. If you delete 20, then 10 should hold the address of 30, 30 should hold the address of 10. If you are deleting 30, then 20 should point to 10, 10 should point to 20.
No.
Right. So
Yeah.
this is how we are writing this circular linked. This is for circular linked list. If we see the program, you are able to see the screen, right?
Yes. Yes.
Yeah. Right. Now we are writing the program. So here is our. Actually, I'm not able. Okay, now, so we are taking our main function. We are taking one pointer called last, which is we are initializing it with null.
Okay.
Okay, now at starting everything is empty. This last is nothing but empty, which we have initialized it to null. So we are saying that add to empty list, and we are passing the pointer as last and value as 6.
Okay.
Okay, now when we go to this add to empty function, this is our basic function. So here we have add to empty function. We see this is our function, add to empty function. So here what we are passing is data as well as our pointer structure node. So here what we are doing, we are seeing that whether your pointer is pointing to null or not. It's not null. Okay. If it is null, return. If it is not null, return, because we are saying we have to add to an empty structure, empty list, right? So if it is empty, continue the operation. If it is not empty, return. Okay. Now, if it is empty, we need to allocate memory, because we need to add, right? We need to add a node. So for node we need to add a memory. We need to allocate a memory. So to allocate a memory, we are using something like how much memory is struct node only. So type is struct node. We are naming it as new node, and we are allocating the memory using malloc struct node pointer malloc size of struct node. Okay. Now we have to assign the data. So the data whatever we are passing is 6, which is pointed by this data. So new node data holds the address of data now. Right. Now we need to have link. Link is nothing but second part, which should have address. So last is holding some address. So we are saying last, assign this last to new node. Last, we are saying assign it to new node.
Okay.
And then we are creating a link like last link is pointing to last.
Okay.
Okay. So now next last next is now pointing to last, and last does have a new node. Whatever just node we created, it holds the address, last holds the address of that.
Okay.
And now we are incrementing this last next, we are just creating link to itself, that now it is holding only one node which is last, and last next hold the address of next last. That's it. Now we have only one node, and then we are returning this add to empty function. Now next thing we are doing is, already we have one element which is 6. Now we want to add at end, and we are adding 8 to it. Now if we go to this add end function, now if we see this, first of all we have to check whether it is null or not. Why? Because we are adding it at end. Right. Now after checking that, allocate some memory for this node, and new node holds the data which is now some 8 or 12, whatever data our. Now your pointer, what it should have is, first of all what we should do is hold the address of this, store the address of the head node to the next new node. Now whatever node we created, the address of that node has to be there in the last node.
Yeah.
We have created one node right now. Already we created one node with 6 or 1 you suppose. We have created. Now whatever node we are creating, that address should be there in the last node we created.
Yes.
Right. So we are storing this last next in your new node next.
Okay.
Right. Now your last next new, we are holding this value in this, storing this value in new node next. Your new node next is there.
Okay.
We are assigning that to your last node next.
Okay.
Last whatever we had, that next now holds the value of new node.
Okay.
Okay. Now last next value should hold the value of new node.
Okay.
Whatever we created.
Okay.
And make the last node as new node. Why? Because this is a circular linked list. Now our new node is nothing but last. Whatever we have created is new node, right? Now new node does have, your last node does have the address of this new node. See, last and next does have new node address. Okay, and now we are saying that now your new node is nothing but, we are just naming it as last. Why? Because again when we are creating next node, we should have the address of this last next.
Okay.
Now we are simply leaving 6. First we have created one, suppose 10 only we say. So when you say we have created 10, so what we did here is, we have created a 10 already, but 10 is not holding, 10's address doesn't have anything. So then we created 20. After creating 20, what we are doing is, we are holding this 10, we are pointing this 10 to 20.
Okay.
That we are doing it in this.
Okay.
New node We are just assigning this last next to new node.
Okay.
Okay, that we did here. 10 is pointing to 20 now.
Okay.
Is this clear?
Yeah.
Okay. Now, if we want to add it one more particular, now we have created two nodes 10 and 20, and I want to add one node 5 in between this.
Okay.
Or anywhere. So here we are saying that we are passing three things. One is our node, and the second is your data, and third is your some particular number where we want to pass it. Now, if last is equal to null, return it. Now, create new nodes. Create new pointers, two new pointers. One is new node and the other is p. Now, whatever your last next contains, last was the second node which is 20, that last next address store it in p, assign it to p. Now p points to when we are taking one random pointer and your 20th address, that means p holds the address of 20.
Okay.
Okay, after taking this, what we are doing is now first take this new node, assign memory to it, allocate some amount of memory, and then add the data to it. Now new node holds the data.
Okay.
Right. Now new node next should hold the address of p next.
Okay.
Okay. What does p contain? P is the new pointer which we have taken.
Yeah.
P holds the address of last next.
Yes.
Right. So here
Yeah.
what we are doing, this p next we are just assigning it to new next.
Okay.
Okay. Now put this new node to the next, whatever we have created, this new one.
Okay.
Assign it to p next. P next is equal to new node.
Okay.
P next is now pointing to the next node, which is new node.
Okay.
Next node.
Yeah.
Okay, that means what? P node, P next does hold. Now it is saying that increment, or you can say that P next is equal to new node is nothing but it is pointing to the next node.
Okay.
Okay, so that means after P, whatever new node we have created, we are saying that now next to this P, you have one new node, and which is your some new node, and point to that. Put a new node to the next to P, new node.
Okay.
And now this new node does have a data as well as next.
Yeah.
So that we are saying that if P is equal to last, then last node make it as new node.
Okay.
That's it. This is, you are adding the new node to the last. That's it. That means we are adding, last is nothing but it's an array we are using, or linked list we are using. So we are adding this new node which we created just now to last.
No.
Okay. When we say that you understood, you're able to catch the point.
Yeah. But still little bit what?
Confusing.
Yeah.
This one or whole thing?
No. This is a particular.
This particular. Okay. So here what we are doing is we are taking two new pointers.
Okay.
So we are taking two new pointers. We are naming it as new node as well as P.
Okay.
Okay. Now P will have two things, as this is a struct to node type.
Okay.
So it will also have two things. One is data and the other is what it is next. So here P is equal to whatever is there in this last next. We are assigning it to P.
Okay.
That means last next is nothing but the what you can say, the previously created node. That's it.
Okay.
Last is nothing but our array, right? Linked list array. Linked list.
Okay.
Last is not some last. It's just a name given to a linked list.
Okay.
Okay. So now we are saying that our whatever linked list is there, the next we are storing it in P. Now what we are doing is, so first now where to do that we have. Okay, now what we are doing, we are just checking that we have to add an item at particular location, right? We are saying we have to insert it at particular location. Now we have to add it in between 10 and 20.
Okay.
Right. So here we are saying that if it is found, item is nothing but here the value we are passing where we want to insert it. Now if I say that I want to insert it at second location, so we are saying, or we are I want to have the data after 6 or something like here what we are writing. Now I want to add it after 10. Sorry, 10 is not your what it is. After 2, and the data is 10. Okay. So this is 2. Last whatever we have added front is 2. So I have to add a node after 2.
Okay.
Right. If I want to add it after 2, so first we need to check that whether we have encountered this 2 or not. So for that, what we are doing is, we are checking it with this if condition. If this 2 is encountered or not. P, which is pointing to data, which is that thing but that's next. Here we are checking that whether it holds the address of this 2 or not. If it is equal to 2, then we are going to create a new node after this.
Okay.
I want to place the new node after 2. So here we are simply checking that in our, if we write like if my number is equal to 2 or not. Because I want to enter the data, here we have something like 2 and then 3 or 4. 2, 3 and 2, 3 we have. Okay. 2, 5, 4, 3 we have. Now if I want to add a new node, what I want to do is I want to add it in between 2 and 4, which is 5. So I'm checking that if number is equal to 2, where I want to add. So I'm giving my data that if I encounter this 2, then create a new node and enter the data 5.
Okay. Yeah.
So here what we are doing, we are just checking if P data is equal to 2.
Okay.
If it is 2, then continue this, because I want to allocate my node after this particular node.
Okay.
Okay. Now, after doing that, we are allocating some amount of memory, and we are just assigning it to new. We are naming it as new node. Now, new node is our just created node. Now, new node should have data as well as your address.
Okay.
Right. So My data is nothing but whatever we are passing, which is 5, 10, anything, which we are passing here, data, which is 10. So now new node does have 10 to one part is done. Now it should have address, or it should point to the next one. So here previously we are just taking one node already. Now here new node next should have a value, right? Now what value it should have? What does this new node next should have a value, right? This 5 should hold the address of
4.
This 5 should exactly. This 5 should hold the address of 4. So we are saying that whatever your P, we are just incrementing this, and we are saying that P next, whatever P next address does have, that you store in this new node next.
Okay.
Right?
Yeah.
Clear? This whatever this P is pointing, that P next address now should be stored in new node next.
Okay.
Right? Now what is there? Here after this we need to have one more node. That means what? P next was actually, what is P next? P next is nothing but the address of 2 next.
Yeah.
Right? P was the last node created. Confusing. Okay, I'll just do one thing. I'll just do one thing. I'll just write here something like my new node is 2.
Okay.
Here here this new node is 10.
Yeah.
Okay, 10 is my data. Now what does this 10 should have? 10 should hold the address of P next, right?
Yes.
Now that means what? This was my 10. 10 should hold the address of 4.
Yeah.
Right. So now this should have the address. Now what does this P next already previously contain? Where is the address? Actually, where is the address of this 4? 4's address is in 2. Before inserting this 10, 4 address is in 2.
Yes.
2 does hold the address of 4.
Yeah.
Right. So what we are doing is, this P next is there. Already at starting we are giving like P is equal to last next.
Okay.
Right. Previously inserted node does is there in P. So that P next we are storing it in new node.
Okay.
Which is nothing but 2's address. 2, whatever present 2 node contains, we are just assigning it to new node next.
Okay.
Right? Now what we need to do is, P next should now have a new, new node.
Okay.
Right?
Yeah.
Now, if P is the last node, then what we need to do? Whatever this new node is there, we have to make it last node.
Yes.
But right now, if we say P is equal to last, then last node is equal to new node. Return new node. That's it. Clear? And then what we are doing is, we are saying that increment it. P is equal to P next. Now the P will point to the next node.
Okay.
Increment it. Okay. After incrementing, now we have to repeat this operation till P is not equal to last next, which means that as it's a circular list, we can't check for null.
Yeah.
So last and next is nothing but starting. So we are simply doing this operation till we reach that node again.
Okay.
Okay. Why we are checking with this P is because at starting we are assigning this 2's address, whatever this 2 holds, we are storing it in this P. So we are checking with this again till we reach that node again.
Okay.
Now, if we say deleting a node, just to check whether this is pointing to null or not. If it is not pointing to null, see that whether it holds a single item. If we say single item, then single item means you will have data as well as your next is nothing but it is pointing to the same node. If we have one node, one will point to the same node, right? 10 should point to 10. So we are checking that whether it is single node or not. If it is single node, free. We are using this free to just delete this.
Okay.
Okay. Free is the function to deallocate memory. We are using malloc to allocate memory, right? So to deallocate memory, we use a function called free.
Okay.
Okay. Now what happens if we don't delete it? See, this is very complicated things. We are just taking 2 or 3 nodes, right? But we may have hundreds of nodes.
Yeah.
If we are allocating this in runtime because we are using malloc. That means previously I am not allocating anything while running a program. If I'm getting some data, I'm just entering it. So whenever a new data enters, we are creating a new node.
Yeah.
Like arrays, we say we are not just saying like array of 10 or array of 15. We are just as the data comes, we are just incrementing it.
Okay.
Now, when my work is done, if I don't free this, if I don't delete this we are doing it in runtime. If we don't delete it, it will create problem.
No.
What problem? You will have an overflow. Why? Because if we say embedded systems does have very small amount of memories.
Yeah.
Okay, it's not like our PCs. It does have very small amount of memory. It depends on how much. If you say generally we don't have even 2 GB or 4 GB also. If we want, we can add in SD card.
Okay.
But we will not have that much amount of memory also. Now in that case, if we don't free up the memory, we will just have an overflow and our data will be corrupted continuously, and we may have even segmentation fault also. Why? Because already the data will be your memory will be full.
Okay.
And this memory will be created in heap memory and not stack memory, heap memory, because this is runtime.
Okay.
Okay, so once your work is done, if we will have to free that particular memory using this function called free.
Yeah.
Okay. Now, if we want to delete the last one, or if we want to see the particular node to be deleted, just to go to that particular key and now, okay, so directly we can't delete it, right? Already we have seen if we want to delete a particular node at that time, if it is in between, what we need to do is we need to delete that. We need to change the address. Why? Because here we have seen that if we want to delete some particular 30, then again all the addresses has to be changed.
Yes.
Right? Why? Because now if I delete 20, then 10 should not have 20. 10 should point to 30, and again
Yes.
30 should also point to 10. So deleting only 20, particularly if I want to delete 20, I will have to do 2 more operations.
Okay.
Right. So for that, here we are writing this particular things. Now, here if we see, we found this 20. With this we found this 20. If it is equal to key. Data is 20. Data is equal to 20. We want to delete this.
Okay.
Then find the node before the last node.
Yeah.
Which is 10. Before 20 we have 10.
Yes, yes. Yeah, okay.
Right. So
yeah.
We are taking one temp. We are taking simply temp as well as pointer D. Some 2 extra pointers we are taking, and we are just assigning this our last to your temp. Okay. Now your temp next should point to the last next.
Okay.
Okay. Which is nothing but we are just assigning this temp next to the last next. Last next holds the value of 20, right?
Yeah.
Right now we have not deleted anything.
Okay.
We have just found this last data.
Okay.
Okay. Now what we are doing is we are pointing our temp node to the next of the last node.
Okay.
Okay. So here after this last node we will have this temp node.
Okay.
Right. Then we are freeing this particular memory.
Yeah.
Okay. Now what after deleting we are saying we are assigning this temp next to this memory.
Okay.
Okay. Now we have not okay. Now this temp next does have a value of last.
Yes.
Right. Now here what we are doing is your pointer is actually incremented to this temp next now. We have just added one new node, you can say. Next what we are doing is we are just finding out that your temp next is not equal to your last pointer, and if this is not equal to key, your temp next does hold the address as well as data.
Okay.
Okay. Now temp should have the present value which is to be deleted. No, it's confusing, I guess.
Yes.
Okay, I'll just say you 1 minute. I'll just explain you one. Okay.
ये मैदान देखो, यहाँ सारे तरफ
Now, if you so now I want to delete a particular node, which is suppose last node. Oh, actually we want to just to check out, you understood last node. We want to check that if at all, if any node to be created, if I want to delete second node, right? Now, we are deleting this second node. So, now this is 10. So what we are doing here is, we are taking one more node. We are creating one node, temp. Okay?
Okay.
In this temp, what should be there? You have two nodes. One is your 10, 20 as well as 30 we have. So now I want to delete 20.
Okay.
Right? Now, here what we are doing, we are taking one temp. Now what does this temp should have?
20?
No.
Okay.
10.
Okay.
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 Actually, no, I don't want to store anything in this. I want to insert a node in this. I am taking one node.
Okay.
I am taking one node, and simply what we are doing is, we are saying that this is the node which is there in this temp.
Okay.
And we are not inserting any link. We are just taking, that's it. We are just assuming that this is an what we can say, one virtual node, you can say. We are creating a node which is this before 20.
Okay.
Now this 30 is there.
Yeah.
We have to store that in temp.
Okay.
So now temp should point to 30.
No.
Temp should hold 30 address. Because we are going to delete 20. 20 holds the address of 30.
Yeah.
So now in place of that, we are just making this temp point to 30.
Okay.
Right?
Yeah.
And now delete 20.
Okay.
Okay. And then we are assigning this to your 10 also. Because 10 next should have 30 next.
30. Yes.
Sorry, temp. Temp is pointing to 30. Temp next.
Yeah. Okay.
So temp next should now be 10 next. Right?
Yeah.
While my temp next is not equal to pointer, and temp next data is not equal to key. Key is nothing but whatever value we have assigned. Then temp should have increment the temp next, and then here if the temp next data is equal to key, that means whatever next whatever temp is pointing to next is equal to data. That means what here after this temp next data is nothing but 20.
Okay.
If it is found at that time, what we are doing is we are taking the next pointer, we are storing we are just having this in this, it point to next temp next, and then free this particular memory.
Okay.
I'll do one thing. I'll just change the names actually, because this last it may be confusing. So I'll change the name of the linked list as well as the other variables such that it should be easy for you to understand. Okay. Then again we will see. This is about your circular linked list.
No.
I think you are clear about the other things. Only deleting at this particular in between somewhere it is confusing. I think only this part is confusing for you.
Yes.
Rest of it is okay, right?
Yeah.
Okay. I'll try to write more simple program such that it will be easy.
Okay.
Okay. Now coming to your double linked list. Double linked list should have two values. One is your previous as well as next.
Okay.
Okay. So if you say previous as well as next, here what you should have. So you will have some address of, like here you will have if we have something like 20, 30, 40 as well as 50, then now here double linked list should have this is your head,
Okay.
head 10,
Okay.
and then it should point to 20.
20. Okay.
And here you will have 10 as previous node,
Okay.
data which is 20,
20.
and then it should point to 30.
30. Okay.
So you will have here, every time you will have here two nodes. This 10
Okay.
is pointing to head as well as it is pointing to 20. 20 is pointing to 10 as well as 30. 30 will point to 20, 40. Okay. So our structure node will now have not only next, but you will have even previous also.
Okay.
You will have three elements into it now: data, next as well as previous.
Okay.
Now, if we want to add a data at the front, that means at starting, which is nothing but 10. I want to add 10 if it is not there. If you want to add 10, then this is not circular linked list. So head will be our starting point. So you will have to add it now, right? Allocate some amount of memory.
Okay.
Yes, calling it as new node, and now assign the data to the new node. Right? After assigning the data new node, just make it as head node. because
Okay.
this is the starting point.
Yeah.
Okay. Now, new node previous should not point anywhere. It is a head
Yeah.
node, but
Yes.
10 is not pointing anywhere. 10 previous node has to be null,
Yeah.
right? So here we are saying that new node previous is null.
Okay.
Okay. Now, here if we see, if we are saying that if we have to assign it at starting, then already if at all if something is there at starting, this is not new. Already if at all if any other node is your starting node, at that time what we need to do is we need to say that this is our new node. If suppose already some node is there, okay, I want to have this 5 as my new node. At that time, this null from 10 has to be removed. Now we have created one new node which is null, and we are saying that it does have 5. And now the thing is, it should point to next to new. Next one. Next is nothing but 10.
Okay. Yeah.
Right. But now already 10 does have null. So we have to remove this null from 10. Yes, exactly. Okay, that we are doing it here.
Yeah.
Now, whatever your head previous is there, that is new node.
No.
Now head points to new node. Your pointer head is nothing but your new node.
No.
Okay. Now, if I want to add it at specific position, if we want to add it at specific position, we will have to change it. We will have to change it now 6 things actually. Now, if I want to add it after 30, then 20 holds the address at 20 does. Now you will have 10, 20 and 30. I want to insert in between 20 and 30.
Okay.
Okay. So if I want to insert in between 20 and 30, so my data has to be something like here 15. And here I have your 30. 30 is actually 20, 30 and 40. So here now it has to be changed to 15, right?
Yeah. Yeah.
20 should hold the address of 15 now. Why? Because we are adding a character here, 15.
Okay.
Now 15 should have here 20, and here it should point to 30. At the same time here we need to change it to 15. So we will have to actually do so many operations here.
Okay.
15 and then this 30, 40 is okay. Right?
Yeah.
We will have to change the values of so many nodes here if you want to insert it in between. Right?
Yeah.
Now, first of all, allocate some amount of memory. Okay, and check whether it is first node or not. We are just assigning it after some particular node. Just to check that whatever your previous node is, whether it is null or not.
Okay.
Then allocate some amount of memory, which is our new node now. Assign the data to new node.
Okay.
Next, this is 15. Now, new node next should point to new node next.
Okay.
15. New node next should point to 30.
30. Okay.
Right? That 30 is there in this previous node. Before assigning, before adding new node, this 30 was there here in place of 15.
Yeah.
20 was pointing to 15.
Okay.
So here we are setting that new node next to the next of previous node. Previous
Okay.
node next was 30.
Okay.
Right? Next here. Okay, here I'll write new node is nothing but new node next. Here it is 15.
Yeah.
Previous node it was 30.
Okay.
Now you are pointing it to 30, and here this 30. Not previous node. Sorry, wait, I'm writing. This previous node next value. Previous node next is nothing but sorry, previous node. Previous node was 30. Now new node does have 15, right?
Yeah.
New node does have 15. Where we have to set this 15?
15 or between 20 and 13.
No. What I'm asking is where we need to place the address. I'm saying in between 30 and here. Now your previous node next has to point to new node.
Yes. Yes.
Okay. These three is nothing but these operations I'm saying. 10 should have 15, 15 should have 20, 30 and 30 and 40. This is these three operations.
Okay. New node.
Okay.
Okay.
We need not have this actually, but just for your actually we don't need this address also, as well as we didn't need this also. We need these operations. Now new node is 15.
Yeah.
Right? New node next should have previous node 15. Sorry, previous node next.
Node next.
Previous node next was 30.
Yes.
Previously it was not 15 but it was 30.
Okay.
Right? It's pointing there now. Now what we need to do is we have to set this new node value to the previous node next.
Next. Okay.
We have previously we did this. Now we are assigning this.
Okay.
We were assigning first to new node. Now we are doing we are working on previous node, which is nothing but this value.
Okay.
Okay. So Now what this value will have is new node value, which is nothing but 15.
Okay.
Got it?
Yeah.
Here now this is working for 15. Here now this is 15 and this previous node actually was. Now here this is new node is 15 and this is for your 15, 30, 20. And then new node previous does this 20. New node previous should have previous node.
Okay.
We are incrementing actually, which is pointing to the next node, previous node, next node. And now this previous node has to be added to the new node next. That means what? Here this previous node was 30. This has to be assigned after 15.
Yeah.
So now your new node next is new node next to previous is pointing to the new node.
Okay.
This new node does have this previous value as well as next value.
Okay.
30 as well as this previous node value is 20.
Okay.
Okay, this will be confusing till you practice.
Okay.
Once you start practicing, then only it will be clear.
Okay. Yeah.
If you want to insert a node at last, first of all, the last node should be null, right?
Yeah.
If I want to insert at last, so last node has to be null. So here the operation becomes somewhat simple. Why? Because here 50 does have 40th address as well as null.
Yeah.
Right. If I want to insert an element after 50, then this should have 50, 60 and null.
Okay.
And this should point to 60.
Yes. Double linked list.
Yeah.
Tab you have to change.
Oh, sorry, I'm just checking out what I'm seeing. Thank you. Okay. I was seeing this function. Okay. Allocate some amount of memory. Now, new node data, assign it to data, and then new node next should be null, right?
Okay. Yeah.
New node next is null.
Yeah.
We have to assign address to new node previous.
Okay.
And previous node null has to be deleted with this new node address.
Yeah.
This was null, so we have to assign 60 to it. And here the previous node has to be assigned the address of this. So now we are taking some temporary node. One node we are taking, and we are just saying that this is our starting node. Now, now if we see this,
మార్నింగ్ 6 నుంచి స్టార్ట్ చేస్తారు 6:30 నుంచి కానీ ఈ టైమే మిడ్నైట్ టైమే నాకు ఐడియా లేదు అసలు ఒకసారి అడుగుతాను మ్యాక్సిమం ఉండదు ఎందుకంటే నైట్ కూడా సమ్ 10 వరకు 10:30 వరకు 10 వరకు విన్నాను కానీ ఆ తర్వాత తెలియదు.
Okay, so if it is empty, just make it as head node.
Okay.
ఎందుకంటే
Right. Now, if it is not empty, then we will have to go till 50.
మళ్ళీ చాలా ఎక్కువ
Yes.
If it is not empty, then we will have to first travel till 50 and then insert it after 50.
Okay.
So for that, what we are doing, we are simply incrementing it. Temp next. If it is not null.
Okay.
If it is not null, then just temp is equal to temp next. That means increment the pointer. Point it to the next. So what this will do is 20 will point. 20 is not temp next is not 20 null, not null. Point to 30. 30 not null.
Okay.
Point to 40. 40 not null. Point to 50. 50 is next is null.
Okay.
Right. So it will come out then.
Okay.
Now your temp next is null at last.
చాలా నుంచి
Okay.
Yeah.
This statement simply is incrementing your pointer. That's it.
Okay.
Okay. So now it will reach 50.
Okay.
After reaching 50, now we have to say that assign a new node here.
Okay.
Okay. So temp next. After temp next, we are assigning one new node. We are making one new node.
Okay.
After temp next.
Okay.
Okay. Now, this new node already we created here. Here, this new node is there. This new node already we created here. And now, just a second, my battery is low.
మళ్ళీ ఈ బస్సులు ఇలాంటివన్నీ అయితే ఇంకా అసలు సమస్య లేదు ఇక్కడ. బాగా ఉంది ప్లాన్.
So here what we are doing is, after going to the last, now your last node is, we have gone till 50.
Okay.
Now we are just assigning one new node after this last node.
Okay.
That means we are adding one new node here. After 50 we are adding 60.
Okay.
Okay. So here we are doing that. After reaching null, the temp next, we are just after this we are adding a new node. Now we have added 60. Okay. Now already we have 50 in this. Temp is nothing but 50.
Yeah.
Right. So we are saying that assign this a new node previous with this temp.
Okay.
Right. Now new node previous does contain 50.
Okay.
This is done.
Yeah.
Okay. But still null is not done. So here again. Oh, already we did.
Yeah. Copy new node next equal to null.
New node. Yes.
Yeah.
New node next is already null.
Okay.
So we are just simply saying that assign this to, this 50 we have added.
Oh. Yeah.
This is just inserting new node at last.
Okay.
Now if we want to delete some particular node from the double linked list.
Okay.
Now first of all check that If at all, if your whatever node you want to delete is null, you cannot delete it.
Okay.
Okay. Next, if your that means basically if your pointer is pointing to null, you cannot delete anything. Right now. If we want to delete head node,
Okay.
that means first node. Right. Then what we need to do is here, if we want to delete 5, now we have to make this 10 as head node.
Okay.
That means 10 previous has to be null.
Yeah.
Right. So if your head is equal to the node we want to delete,
Okay.
then what we are doing is we are just point the delete node to next. That means increment this head to the node you want to assign. Make this head, make the delete node next as your head.
Okay.
Delete node next is nothing but, now here 5 was there. 5 next was 10.
Yeah.
5 next, here 5 next was 10. Right.
Okay.
So we are making this 5 next 10 as your head node.
Okay.
See, just to make this as head. Which node? Delete after delete node next. Delete node next does have 5. This is 5.
Yeah.
So make that as head node.
Okay.
Okay. Now delete node next if it is not equal to null.
Okay.
Okay. That means whatever node we want to delete, if that next is not null, which means what? Last node. This was for head node. This is for head node. This is for last node. If it is not if this is last, if it is not last node, if we say last node next is null.
Yeah.
Right. So if it is not null,
Okay.
then what to do? That means what? Delete node next as well as previous.
Yeah.
Has to be given delete node previous.
Okay.
Okay.
Yeah.
Why? Because here we have to add, we have to change it like if I want to delete this 30.
Okay.
If we want to delete 30 at that time, what we need to change? This 15 has to, okay, I'll just remove this, we have this 15. If I want to delete this 30, at that time, what are the changes we need to make is, 15 should hold address of 40. And 40 should hold the address of 15. That means 15 next and 40 previous.
Okay. Yeah.
Same thing. Delete node previous as well as next. Which means what? Delete node is nothing but 30.
Yeah.
Right? 30 previous and 30 next.
Next. Okay.
This has to be given to delete node next. Delete node next is nothing but 40.
40. Yeah.
Assign this.
Okay.
And then 3. This
Three,
day.
Okay. Yeah.
For printing, already you know, just if till this is not null, print it.
Okay.
%id,
Okay.
whatever is there pointed by your node, which is data.
Last. Okay.
Last node is equal to node next, which means increment the node. And check that whether that node is null or not. Again print it.
Okay.
Okay. If it is equal to null, just print null. That's it.
No.
This is your double linked list.
Oh.
Actually, I'm facing some problem with this Ubuntu. I don't know VMware or because of my system or not. I'm just checking, but no, I'm not able to detect the problem. So what I'll do is I have already these programs. I think you understood. I have to execute this, but yesterday also, as I said, I'm trying to do, but it's making some. This is giving some error actually. So I simply have to copy this and paste it there. That's it, and run this. Okay. So coming to Q, double linked list is clear, right?
Yeah.
Now coming to Q, as we discussed, Q is nothing but first in, first out, or not?
Yeah.
Yes, first in, first out.
No.
Now here we will implement this Q. So we are using three functions: NQ, enter the data into Q; DQ, delete, display.
Okay.
Okay, so we are taking Q size as 5.
Okay.
We are taking two variables. One is like top. In stacks we use to top, right?
Yeah.
Like that we are here. We are taking two variables. One is front and the other is rear.
Okay.
Okay. Now, when you say starting only, if you say DQ, there are no elements, so you cannot delete anything, right?
Yes.
So first we will just enter 5 elements into it.
Okay.
So if we see NQ, now in NQ you just, this is our NQ function. Now we will see that if this rear is equal to size minus 1.
Okay.
Okay, rear is minus 1. We have initialized it to minus 1. Right?
Yes.
Minus 1 is equal to size minus 1. Size is nothing but 5.
5.
5 minus 1, 4. Right. So minus 1 is equal to 4. This condition fails.
Yeah.
It will go to else.
Okay.
Now check that if front is equal to minus 1. Yes, front is right now minus 1.
Yes.
Then make front is equal to 0.
Okay.
That means simply increment it.
Okay.
Okay. At the same time, increment rear plus plus also, because one element is added to it.
Okay.
Now the front as well as rear element is only one. Front is only rear.
Yeah.
That's why we have incremented rear also.
Okay.
Okay. And now this item rear, which is 0,
Okay.
is equal to the value we are assigning, which is nothing but 1.
Yeah. Okay.
Okay. And then just to print, insert it.
Okay.
Okay. Here item is nothing but whatever array we have taken.
Okay.
Okay. So we are assigning, we have entered one value actually, one element. Now if we see again, it becomes 2. Again, this rear already is 1. Yeah, rear incremented to 1. This is a global variable, right? These are global variables.
Okay.
So this element will retain its value. So it becomes 1. 1 is equal to 4. No, condition fails. Again it will come to front. If front is equal to minus 1, make front equal to 0. But this condition fails. Front is equal to minus 1 only, right? Then front becomes 0 and we are incrementing rear to 1, 2. Item of 2 is equal to this value.
Okay.
Okay. So this is how we are entering elements into here Q.
No.
Okay. Now Here we are not incrementing front value, we are incrementing only rear value if you see. We are just checking this front only once.
Okay.
I mean every time we are checking because this is in else condition, but we are checking it only for -1. If it is -1, make it 0, that's it. Otherwise we are only incrementing this rear.
No.
Okay. Now, if you want to delete some elements from Q, if you want to delete, first of all we have to check that if it is equal to -1. You check for front or rear, doesn't matter, but we have incremented rear already.
Okay.
So that's why we are checking for front.
Okay.
There is the reason we are not incrementing both, because one we are checking it for NQ and other one we are just checking it for DQ. So front is equal to -1, that means Q is empty. Okay. If at all, if front is equal to 0, that means some elements are there in Q.
Yeah.
Right? If we enter some elements, already we are saying that make front is equal to 0.
Okay.
So if there are no elements, front will be -1. If there are any elements in the Q, front will become 0 and this condition fails.
No.
It will come to else.
Yeah.
Okay. And then increment front plus. Now, if front is greater than rear, make it. If suppose we are entering 1 is greater than rear, how many elements are there depending on that? If your front is greater than rear, when the front will be greater than rear? If all the elements are deleted?
Yeah.
When your front will be greater than rear? If all the no elements are present.
Okay.
Right?
Yeah.
At that time, make front is equal to rear equal to minus.
Okay. Yeah.
That's it. This is your PQ and NQ operation.
No.
Why we are saying front is greater than rear is because it's not necessary that I am not saying that you are incrementing rear only when you are entering elements.
Okay.
Okay. And you are incrementing your front when deleting it.
Okay.
Okay. So you may have rear as 5 also.
Okay.
But when you delete it, like I have entered 5, so front will be at starting 0 only.
Okay.
Front when entering elements is 0 only.
Yeah.
We are incrementing only rear. So I have entered 5 elements. So rear value is 5, but front value is 0. 0 is greater than 5. This condition fails.
Yeah.
This will not execute.
Okay.
But when you start deleting, at that time you are saying that delete the elements, it becomes 1, 2, 3, 4, 5.
Okay.
After deleting these 5 elements, 5 is greater than 5. We are not incrementing your rear. So rear is 5 only. Front is also 5. So 5 greater than 5. There are no elements present.
Okay.
That's why we are saying assign is -1 again.
No.
Okay, is it clear?
Yeah.
This
But
is
that
your,
should be front greater than or equal to rear, right?
sorry?
Front greater than or equal to rear. The DQ.
We can write it. We can write it, no problem.
Oh.
Actually, yes, greater than or equal to also we can write, but in that case there is a chance that there might be one element.
Okay.
Rear is 5.
Okay.
So front, if it becomes 5 greater than or equal to 5. Okay, after deleting it's same only. So front greater than or equal to will also work.
No.
No problem.
No.
Okay. Coming to your display function, if rare is equal to -1, there are no elements in the list Q.
Okay.
Okay. Else, take one variable and just traverse through that Q. If I is equal to front is nothing but 0, because when entering front becomes 0.
0. Okay.
So I is equal to front, I less than or equal to rare. We are incrementing it while entering number of elements. So if we enter 5 elements, we will get I less than or equal to 5, I plus plus printf items of I. That's it.
Oh. Okay.
This is about your Q. Now in Q again you have different types of Qs. 4 types of Qs are there again.
Okay.
This is simple Q.
Okay.
You'll have circular queue, you'll have priority queue.
Okay.
I'll try to write one example for all and I'll show you. Okay, so this was about your, but basic queue is this way. Okay, so you will have, now we are done, only one thing is left and that was in circular linked list. One function I have to write which has to be made clear actually to insert a node after specific node, right? This was not clear. This is not clear.
Yeah. Yes.
Okay. Other than that, everything, even reverse is clear now, right?
Yes. Yes.
So we are done with linked list, circular linked list, double linked list, queue, stack. Stack already we have seen yesterday.
Yeah.
Right, this was also clear.
Yeah.
Okay, so we are done with this. Now coming to your non-linear, these were all linear data structures. Linear data structures are nothing but if either we have contiguous memories or we have memories which does have some address or either next or previous. Okay, they are not even though they are scattered, we hold the address of the data, like where it is next to.
Okay.
Okay, but when you say what it is, non-linear data structure, non-linear data structures are scattered.
Okay.
So these are like trees and graphs.
Okay.
So we will see trees and graphs tomorrow. If this is installed, I'll just execute this. If not, I will have to wait. Will you be available in day today?
I think I have to go to office now.
Okay,
After
okay.
8 or 9. Or it's tomorrow.
Yeah, mostly it's tomorrow only, but just I'm asking why, because if it after it installs, if you are at home, I mean work from home option, I'll just show you. If not, tomorrow morning. No problem. Anyway, already we have seen all these things. Just we will have to execute this. That's it. I need not explain you again. So that should not be a problem. So only 2 topics, small topics again are there. Infix, postfix we have not done yet. We have not written any program for infix as well as postfix, and prefix. So I will just write the programs for that also, as well as the trees and graphs. So by this weekend mostly we will finish this topic.
Okay.
Okay. And what I'll do is I'm not able to just to make all the programs. So what I'll do, just depending on the topic, I'll just whatever programs I have, I'll just make a WinRAR file and I'll forward it to you.
Okay. Yeah.
Okay, because actually I was trying to gather all the programs together for all the topics and I was going to send you, but rather than doing that, now I'll just whatever programs already I have or the topics which